I graduated in mathematics. I got my master's degree and PhD degrees in Brazil, and I worked as a researcher in Brazil and in Germany before coming to the US. And my native language is Portuguese. Okay. Okay, so today is the day to discuss R. Let's see how we can start using R, where it is used, some packages to use for data science, and some tools to make programming in R easier. So we'll also review how to get started with writing code and creating your portfolio. Let us ask the same question we asked when we were talking about Python and the other webinars. Why should I use R? Why is it significant, right? What kinds of problems does it solve? As in, why should I use R instead of another language? Let's talk a little bit about its history first, and we go from there. The two people here are Robert Gentleman and Ross Ihaka, and they were the ones to start the R project at the statistics department of the University of Auckland in New Zealand. But since R is an open source language, more than that, R is free software, but I won't enter into the differences here. The R language we have today is the result of contributions from the whole world. R, the language, is derived from the language S, a statistical language designed at Bell Laboratories in 1976. Then, in 1988, a commercial version of S was released with the name S+, and this version still exists. But in 1991, Robert and Ross decided to create an implementation of the S language that was independent of S+, this commercial version. And that implementation received the name R, and they began publicizing it in 1993. So R became free software 2 years later in 1995. So if you need anything related to statistics, if you need free and open source, like R is the way to go. When you install R, you have a set of packages called the R base package. This main package contains basic functions for arithmetic, input and output, basic programming support, and so on. But R also has its R package repositories, right? So the most important one is called the Comprehensive R Archive Network, or CRAN. While I was preparing this, the CRAN package repository had more than 18,000 packages available. And all packages in CRAN go through its repository policy in a way that they are not accepted if they are not up to CRAN standards. So if you're using Windows or Mac, you'll likely install R from CRAN as well. So as we said, we have lots of packages for R, right? So, however, we also have the tidyverse, a collection of R packages that are designed specifically for data science, sharing the same design philosophy, grammar, and data structures. So these are the core packages that compose the tidyverse, and we introduced them at our first webinar, but today let's look at some of them in a little bit more detail, okay? Let's start talking about ggplot2, a system to create graphics. It's ggplot2, right? But I refer to it as ggplot only, okay? So, to make it easier for me. So ggplot is based on this book here, The Grammar of Graphics by Wilkinson. The book discusses the rules behind the production of different types of charts and plots, and ggplot incorporates these ideas into its principles. So you provide the data, you tell ggplot how to map variables to certain aesthetics, what graphical primitives to use, and it will generate an elegant plot to you. you can even use extensions for ggplot, adding more capabilities to it. Some examples are ggAnimate, which has functions to create animated plots, and ggstatsplot, where you can add results from statistical tests to your figures, okay? Now, let's talk about dplyr. I did my research and it's pronounced dplyr, okay? So it will help you in the most common data manipulation tasks, and you can use it to change the ordering of the rows, to add new variables based on the ones that you have already, to pick variables according to their names, to reduce multiple values down to a single summary, and more. Now, tidyr, if we are certain that our data is tidy, clean, when we're working with it, we'll spend less time fighting with the tools, right? And we can pay more attention to our data analysis. So tidyr helps us to create tidy, clean data. According to them, tidy data is the data where every column is a variable and every row is an observation and every cell is a single value. Okay. So next we have reader. It provides a fast, easy way to read data from CSV, separated value files, files with values separated by tabs, or data with fixed width. Compared to the functions in RBase, reader functions are generally faster with consistent names for the parameters. And instead of using code loops provided by BaseR, you can use some of the tools in Purr, and it provides functions that eliminate the need for many common code loops. So very repeated code repeated very often. So as with other packages on the tidyverse, Purr is more consistent amongst itself than BaseR. So, for example, let's say we want to solve a problem for one element in our data. Once we solved it, we can use Purr to generalize our solution to all elements in the list. And this is especially useful when you have tens of thousands of elements in your data, okay? And finally, we have Typo, a more modern type of data frame. So these data frames are lazier than the usual ones. So they don't change variable names or types. They don't do partial matching one thing with another without you knowing it. And they will complain, for example, when a variable does not exist. They won't fix it for you. So this kind of behavior makes you solve problems earlier, and it can lead you to cleaner code. So there are more packages in tidyverse for more specialized applications, but these are the core ones. And they all behave as one toolkit, or one whole toolkit. So with tidyverse, you have a full set of tools to read, to clean, to analyze, and to present our data. So I said that at the first webinar, but let me repeat it. There's a lot of knowledge here, okay? And you don't need to know everything at once, all right? So, all right. So now that we know some tools that we are going to use when doing data science, let's discuss where we are going to work, okay? So I will feature just 2 tools here, but they are more than enough for you to start working. So I'd say that it's a crime to talk about R and not mention RStudio. So it's a great IDE, an integrated development environment with a console, with an editor that supports code execution directly, and tools for plotting, some history, debugging, and so on. And it works for Python as well, not just for R. And then we have Shiny. Shiny is an R package that helps you to build interactive web applications straight from R. So Shiny apps are easy to write, and you don't need skills on web development to build them. So if you'd like, though, you can also extend your Shiny apps using themes, HTML, and JavaScript, but you don't need to. All right, so we saw a little bit about why and where to use R. We also saw the tidyverse, a set of tools to work with data science. Now, how do we learn how to use R? How do we use these tools? How do we learn some techniques and create our portfolio? So we already discussed it on the last webinar, but please let me repeat myself here. So you see that the process is the same whether you're using R or any other language, okay? So before anything else, please let me recommend this book, R for Data Science, okay? It's an awesome book. I read it for this talk, and it will certainly use it. I will certainly use it a lot for other things. So it's available freely over the internet, and it will help you on installing R Studio, so you can start coding at once. Okay, so it has lots of exercises that can be used in your portfolio as well. Let me talk about Kaggle basic competitions again. While Kaggle has lots of competitions where you can earn money, there are some that will provide you with knowledge on or some kind of data or something like that. One example is the Titanic one, where you will predict which passengers survived the Titanic shipwreck. Okay, this is a very well studied challenge already, and almost everyone in Kaggle has a solution for that. So most of the solutions are open, and you can learn from others as well. You can also go through some tutorials and challenges, but it would be awesome for you to check Our Ladies and Meetup for our conferences. They are a great place to learn more and also to meet people interested in data science, okay? So you can go to the Meetup page, you can type R plus data science and your place, and you're good to go. So you can check also the Our Ladies page, and maybe you will find a chapter close to you. However, most of the meetings happen online nowadays, right? So you can watch them from home. You don't need to be close to one of these. So these meetings can give you a lot of different ideas and information, even on work opportunities, okay? And when you're more seasoned on how to work with data, you can work with some open repositories and work on their data. So you can use what you have learned so far on tutorials, on Kaggle, on that book, and explore different approaches for a data set on your city, for example. So you can check if you use that data freely first, please. So you need to check if it's free for you to use or not, because however, most of the open data most of the open data sites will let you know if there are limitations on the use of that data and when you're free to use it or not. Sorry about that. We're going backwards, not my intention. While you're doing these things, it's interesting to put all your work on GitHub, as we saw previously how to do, right? So you improve your GitHub skills and you have your portfolio ready when you want to apply for a position, okay? So all the solutions for your Kaggle competitions, your versions of the tutorials you have followed, your ideas, so on, all you can put all in there, you can add all in there. And If you're in doubt on how to use GitHub, please check our last webinar on GitHub. We have tips on how to open your account, and a step-by-step example on how to add data to a repository. So don't forget to give credit to the code, to the tutorials, to the tools and data you used. So cite them on your portfolio. Remember to include acknowledgement for other people's code, for example, and what else do they need you to do, they ask you to do when you're using that data, okay? And to finish, you can gather all the new knowledge and start a data science blog. This will make you and your work more visible, and the blog will be seen as part of your work portfolio as well. And at the end, you will learn how to communicate your ideas more clearly when discussing your work, and also outline how your working process happens. So the companies will learn how you approach specific issues, specific problems when they have it, okay? You can practice, for instance, explaining the results you had from some experiment on Kaggle, or present something you learned at a meeting you had, a meetup, or Our Ladies. You can also create tutorials on the tools you're using and write about what worked and what didn't when you're applying the skills, you learned for some specific problem, all right? All right, everyone, I guess that's it for today. However, since we already talked about Python and now R, just a small point on learning languages before we finish, okay? So before coming to the US, we, as in we, immigrants, so we learned some English. So in Brazil, we joke about that. So when someone asks you, hey, how good your English is, and you want to answer that you know the basics, we say, I know my book is on the table, you know? So I don't know why, but it's one of the expressions that we repeat a lot in Brazil to say that we know a little bit of English, okay? For instance, me, I started learning English translating Iron Maiden songs at the school PC. So I'm not sure about your situation, if you had English at school, if you had a private tutor, or if you are self-taught, but you learned some words and then some sentences and so on. Then we came here to the US. We have our own communities, our own friends, but we also have lots of possibilities to speak and practice our English, right? And then again, every day we learn something new, a new word, a new expression, okay? So please think about that when you're learning a new tool, a new programming language. So it's not something you learn in the sense that there's no ending. So no English speaker, not even a native, knows everything about the language. Not every word, not every grammar rule, not every dialect. So you can always learn something new, right? But see a language as something you participate in, not something to be learned, something to participate in. It's a tool to bring you closer to a community, you know. So we don't want to be the knower of all things. We want proficiency. We want to be good at using that language to solve the issues we have. So think about learning a little bit at a time. So a tutorial, and then a project at a time, and you will be proficient sooner than you think, okay? There are some resources here at the end, as always, that you can use to learn more about R. And we also try to add some books and courses that you can access with no cost to complement the ones that you have access with the UpGlo partners, okay? And we're finishing for today. Again, please ask anything about R and data science, and I'll try to answer questions to the best of my knowledge, okay? So the slides and the transcript of this talk will be available for you later. And thank you again for being here. So over to you, Ceci.
Thank you.